Right, guys. Good evening. Hi, Raghuveer.
Hi, Kranti.
Hi. Hi.
Good
So
morning.
yesterday, morning. So yesterday we have seen how we can use joins. We have seen different types of joins like equi joins and non-equi joins, and within them we have seen what is an inner join, outer join, and a self join. So within outer join, we have seen left outer, right outer, and then full outer joins, and have seen rules to perform joins, and we have seen with examples and with depictions of how different types of joins function in Tableau. And we have also seen that a default join is a inner join in Tableau. Also, we have seen that there are two ways to implement joins, that is automatic way and uh, manual way. So we also have looked at cross database joins, wherein we can use tables from different databases and then join together starting from Tableau 10. Okay, so we have worked on few of the tasks and examples to understand these concepts in yesterday's class. So after that, we have looked at cardinalities. So to decide which type of a join we have to use in the Tableau work. So we have to first look into cardinality types. So we have looked at different types of cardinalities: one to one, one to many to one, and many to many. So based on the relationship type of the relationship, so we can um, choose different join types. For example, for one to one cardinality relationship, so we can use inner join, whereas for one to many, right join, and many to one, we have to use left outer, and full outer we have to use for many to many we have to use full outer joins. So these are the things that we have looked at, and after that we looked into data blending. So how we have seen how we can blend two different data sources and get a resultant set. So we have seen what are the rules to blend data, and how what are the ways like automatic and manual way to perform data blending. So we have performed a few tasks and examples to understand data blending. So those are the things that we have covered yesterday. So today we'll be covering sets and bins. We'll be covering sets and bins. So what is a set? So what is a set? Set is nothing but a custom field. Means it is a manually created field in Tableau. So it contains a required subset of the dimensional data. So so these are all the dimensional data. So you can create a subset of these dimensions using sets. Using sets. So in Tableau, there are two types of sets. There are two types of sets in Tableau. So one is constant set. One is constant set. The other one is dynamic or computed set. You can also call it as dynamic, computed, or conditional set. So one is a constant set, another one is a dynamic, computed, or conditional set. So which constants in constant set, the data is always constant. Okay, so in a constant set, the data is always constant. If the set is not having any condition, then it is known as a constant set. Okay, so if you create a set or a subset of these dimensions, that is called as a set. And if a set is not having any condition, or it is always constant, and when the data is always constant, that type of a set is known as a constant set. Whereas sets based on conditions are known as dynamic sets. Sets based on conditions. are known as dynamic sets. We can also call them as computed sets. Dynamic sets, computed sets, or conditional sets. Okay, dynamic sets, computer sets, or conditional sets. So the data in dynamic or computed set will change every time based on the condition or computation. So the name itself is indicating that it is a dynamic set. So the data is not constant in nature. So it is dynamic. So it will change, the data will change every time based on the condition or a computation that you define in the set. Okay, so you can define a condition or a computation in the set. So based on that, so the data in the dynamic set always changes based on the condition or a computation. So we'll perform a task to understand this. So we'll create constant and dynamic sets for uh, top 10 customers based on sales. Okay, so first we'll drag customer name into rows, and then sales into columns, and then we'll click on descending order in the toolbar. So this will create a list of all the customers based on sales. Now we will select first 10 customers manually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 items are selected here. And you can see in that status bar also 10 out of 3403 marks. So 10 customers are selected manually here. So in the, you will get a tooltip after selecting the customers manually. So you'll get a tooltip. Okay. So I'm selecting that again. By selecting the top 10 items, I'll get a tooltip like this. This is called a tooltip. I'll get a tooltip. So in the tooltip, I'll click on create set. So this is the icon for creating a set. So a set is indicated by a, a, a icon like this. Okay, it is indicated by an icon like this. It is a Venn diagram icon. Okay, so click on create set here. Click on create set, and you enter the set name as top 10 constant. So we are first creating a constant set, top 10. So because top 10, so there will be only 10 customers at any point of time. So this is a constant set, because this 10 is not dynamic in nature, it is a constant in nature. So 10 will not change anytime. So because we are selecting only top 10 customers, so it is constant in nature. So this is a constant set by nature. We'll click on OK. So this is having top 10 customers in it. This set is having top 10 customers. It's a constant set. Click OK. Now remove the customer name from the rows. So you don't want this because we already have a set. So drag the top 10 constant set into rows. So after you create a set, so it will be created in a sets tab. Okay, you have under data window, you have dimensions, measures, and also sets and parameters. We have 4 tabs, right? So within that, a sets tab will be created, and it will be in sets tab. So top 10 constant is a set that you have just created now. Now drag this and um, drop it into rows. By default, you will get in and out in when you create a set. Now right click on that set and click on show members in the set. So and also sort it. So this will create top 10 customers. Okay, this will show you top 10 customers in this view. So basically you have created a set of customer names having only top 10 customers in it, and we are showing that in a in rows. So top 10 remains constant, so this is called as a constant set. This is one of the examples for constant set. Now we will create a dynamic set. Now we'll create a dynamic set. We'll right click on the customer name now and select create set. Right click on it, click on go to select and click on set. So now you enter the set name as top n customer dynamic. Top n customer dynamic. This is a dynamic set that we are going to create now. Click on top, by field, select by field and select top here. Select top here because we want top n. And in just beside top, you go to create a new parameter. Select create a new parameter. This will open a pop-up window like this. You create a parameter with name top n. Top n. So click all. It is an integer. So current value you can keep it as anything, a default value. Display automatic. Select all allowable values and click on OK. So this is a top n parameter which has been created. Now we want to show top n customers based on sales. So we have to select sales, sum of sales here. Just select sales and the aggregation is sum. Click on OK. Now right click on the parameter top n and click on show parameter control. And set the parameter value to 10. Okay. Set the parameter value to 10. So here we have to give top end dynamic value in rows and sales in columns. So right click on the set and click on show members in the set. So you change the parameter and you'll see those number of customers in the view. So if you give 15, you'll get top 15 customers. If you give 20, if you give 20, you'll get top 20 customers. Similarly, if you give 7, you'll get top 7 customers. So this is called as a dynamic set. So this is a dynamic set. Okay. So based on the value that you enter in a parameter, you will get the view. You'll get the top end view dynamically changed. You can sort the view as well. Okay. So this is called as a dynamic set. And here we have seen how we can create a constant set. In constant set, we will have only a defined number of rows. In dynamic set, we will have the option to give in our own user defined number, and based on that input, the output of the visualization changes. The number of rows will be shown based on the input given in the parameter, right? So we have to note here that if we create any set, Tableau will place that set under the sets tab of the data window. Okay, so when you create a set, so it will be created under the sets tab of the data window. Similarly, a parameter also will be created in a parameter tab of the data window of the data. Under data window, we have 4 tabs: dimensions, measures, sets, and tabs. When you create a set, it will be created under sets tab. So so like this we can create a dynamic and constant sets. Also, few points to note here are, so if we create any set and if we drag it into row shelf or column shelf, by default Tableau will display in and out. Tableau will display in and out like this, show in and out. So it will display in and out like this. This is called as a in and out mode. So where in indicates that members inside the set. So these are the if in indicates the members inside the set, and out indicates members outside the set or the condition. That means in indicates uh, the members inside this inside the condition, and out indicates the members outside the set or a condition. You can also say that in means true and out means false. So based on the condition, in means these are the members based on which is satisfying the condition. So out means these are the members which are not satisfying the condition or false. So basically set is a boolean field because it's true and false. Okay, right. So to display the values in the set, so we need to right click on the set and then show members in set like this. So we'll click on show members in set. So now we'll be able to see the members in the sets like this. Okay, so in any set, values are known as members. So in dimensions, we call the entries in the dimensions as values. So we are calling them as values. However, in a set, we call them as members. In a set, we call them as members. Okay, these are all members. So the set values are called as members, whereas dimensions in dimensions the entries are called as values, right?
So Kranti, so in terms of constant sets, so let's say if you are connecting to the live database and all, the sales might have been changed over a period of time. So in that case, it won't be, those customer names will be stagnant all the time, or if it is sales get changed and customer name got changed, then in that case, dynamic set would be a viable option on that.
Yeah, see, when you refresh the data, the
Mm-hmm.
top 10 customers would be in this. See, the condition is defined here, right? So
Mm-hmm.
if you go to, yeah, so in this case, what we have done is we have
Mm-hmm.
selected 10 entries and created
10
a,
entries. Yeah.
so these are constant in nature.
Mm-hmm.
However, so if you create a same constant set with a condition, so we will be able to
Mm-hmm.
get a dynamic top 10 customers based on the updated data or up to date data. However, in this case, you will be able to see that. So in this condition, dynamic condition, we are defining a set, defining a condition here, top 10. So this will actually bring in top 10 customers dynamically. If you refresh the data, and obviously the data changes, so then the fresh
Mm-hmm.
data top 10 members would be displayed in this case. Okay, so if you use this option, you will not get top 10 data based on the refresh data. You will not get it.
And is this top 10 constant is shared across multiple sheets, or only it is fixed to that sheet?
This is on a sheet level, right?
Sheet level. Okay.
Yeah,
Yeah. Yeah. I just want to make sure. Okay.
yeah. So in within the sheet level, you have made your own selections of top 10. Okay.
Top 10. Yeah, okay.
So yeah, if you in the second sheet, if you make few more as your selection, it's top 5, or you
Mm-hmm.
can select any customer as your wish, right? So here we have on a sheet level we have selected on a top few 10 customers. So this is a constant set that we have defined here.
Okay.
So if you want that, if you want a dynamic customers based on the refresh data, you use the dynamic top end condition. That is ideal. Yeah, that is ideal.
Okay. Yeah. Thank you.
Yeah. So we'll move on to the next task. So we'll display the profit contribution of all the countries whose sales are more than 100,000 every year. So we'll display profit contribution of all the countries whose sales are more than 100,000 every year. So we'll right click on country or region here and create set. In condition tab, we'll select by filter and select sales using aggregation as sum and greater than 100,000. Click on OK. So we'll drag country with sales greater than 100,000 set. Okay. So this is the set that we have created. So we'll rename this as country sales greater than 1 lakh. So we'll drag this set into rows and profit and year into columns. Right. So one other way to do is to see, now we want to select the percentage of profit contribution. So we want to display the profit contribution of all the countries. So we'll show it in percentage. So we'll go to analysis tab and select percentage of pain. So why are we selecting percentage of pain here? So we, we are dividing the view into different panes based on years 2010, 11, 12, 13, 12 and 13. So that's why we'll show percentage based on panes here. Okay, so we are basically dividing that into panes. So now we'll show members in set. So this will display the profit contribution of all the countries whose sales are more than 100,000 every year. Okay, so this will show profit contribution of all the countries uh, whose sales are more than 100,000 on each year. So using sets, we can create a view like this. So one more important thing is you can display top end customers based on sales and percentage contribution also using sets. We'll see how we can do that. So even for top end customers, we can use sets. So we'll display top end customers based on sales and their percentage profit percentage contribution. So we'll right click on customer name and select create set and name it as top n and select top here by field. We'll select top and then top n as parameter, top n parameter. by sales. The aggregation is sum. Click on OK. Will display top n parameter like this. We'll drag top n set into rows and profit into columns. We'll click on analysis and select percentage of table because we have only one table here. So we'll choose table and click on show members in set. So this is displaying top n customers. So if you change this, you will get top 5 customers also. Okay. So you can sort this view as well. So we're getting top n customers based on sales and their profit percentage contribution like this. Okay. So we have to note here that on measures, it is not possible to create any sets. So we are creating sets only on dimensions here. So on measures, it is not possible to create sets. So this is also one of the important questions or important things to remember in real time scenarios. So it is not possible to create sets on measures. We can create sets only on dimensions. Okay, so we'll go to the next topic called combined sets. So what is a combined set? So in Tableau, it is possible to combine two sets into a combined set. Okay, so if you are creating two sets, so there are multiple sets here. So it is possible to combine two sets into a combined set if those two sets are based on a single dimension. So if two sets are based on single dimension, so that is a condition here we have to note. So if two sets are based on single dimension, coming from single dimension, say country, for example, if two sets are created based on country, we can combine those two sets. So those type of sets are called as combined sets. Those type of sets are called as combined sets. Okay, so there are different ways in which we can combine two sets. There are different ways we can combine two sets. Okay. Combined sets and ways to combine two sets. Okay. So we'll see those. So the first way is all members in both the sets. So there are two sets, set 1 and set 2. Set 1 and set 2. So in the combined sets, so all members in both sets is represented like this, where in set 1 and set 2, if you take all the members, so this is one of the way. So there is one more option. The second option is common members in both the sets. So here so this is set 1 and set 2. So in common members in both the sets, we will take the intersection of these two sets. So the third option is members part of only one set. Only set 1.
So this is pretty much mathematics concept, A union B, A intersection B. Is that
Yes,
right?
yes, yeah.
Okay.
So similarly, so we have to take this first set only. Similarly, so the fourth one is members part of only set 2, where you will take only the right side set. Okay. Okay, these are the different ways in which you combine sets. So the first is all members in both the sets. Second is common members in both the sets. Third is members part of only set 1, and fourth is members part of only set 2. Okay, we have to note here that if you are working with historical data, we can use constant sets, and if you are working with current data, we can use dynamic sets. Okay, so to answer your question, Raghuveer, so if you are using if you are working with only historical data, we can use
Mm-hmm.
constant sets. So if you are working with current data or real-time dynamic data, so you have to use dynamic sets. Okay, so now we will to understand this concept, we'll actually perform a task. So here, so we'll display common customers based on top 10 sales and top 10 profits. So, so here we have we have all these sets, right? So using this concept, we'll show common customers based on top 10 sales and top 10 profits. So in first option, we'll show all customers, and in second option, we'll show only customers part of sales, and in third option we'll show only customers part of profits. Okay, profits excluding matching. Okay, so the common customers based on top 10 sales and top 10 profits would be this option. So we'll see that with an example. So we have to create two sets on customer name for this. So we'll create two sets, top 10 customers based on sales and top 10 customers based on profits. Based on top 10 customers based on sales. Sum of sales. Okay. So I'm duplicating this, editing the set. I'll make it as profit. Top 10 customers based on profit, and change the condition to profit here. Now I've created two sets. One is top 10 customers based on sales and top 10 customers based on profit. Okay, I have two sets ready now. So in the sets tab, we have to select these two sets. So just now created set, we need to select by pressing control. Okay, we need to select two sets created. Okay, and select, right click on it, and then select create combined set. Create combined set. In the combined set create set window, so we have to uh, enter the name as common customers. So we'll create four sets here. So we'll create one by one. Common customers, and select shared members, and select shared members in both the sets, and shared members in both the sets. Okay, and click on OK. So this will create common customers like this. So I'll duplicate this and I'll edit this set and click on all members in both the customers and rename this as for all customers. For all customers. Okay, and click on apply. OK. Again, I'll duplicate this, edit set. So we have on the left we have profit, and then on the right we have sales. Okay, we have profit and sales on left and right. So if you select the left option, top 10 customers based on profit, so this will create a set for only profits. So we'll name it as for only profit. Click on apply and OK. We'll duplicate this and edit this and rename it as for only sales, and click on top 10 customer based on sales, because the sales field is on the right. Okay, sales set is on the right. We'll click on apply and OK. Now we have created four different sets based on the concept called combined sets. Based on concept called combined sets. Now we'll drag the four sets into four different sheets and select show members. Okay, so these are the members which are common. So basically we'll create one more sheet like this, and then based on the requirement we'll change that to for all customers as well. Okay. Okay, so we'll use these uh, combined sets based on our requirement in different sheets like this. Okay, so now we'll create uh, one more scenario. This is one of the most important scenarios and also very useful scenarios in real time, and also one of the frequently asked questions in interviews as well. So you may be asked how you can display top end and bottom end customers based on a measure in a single view. So that can be accomplished using sets. So we'll see how we can do that. So now in this task, we will display top end and bottom end customers based on profits. So we'll create two sets on customer name, top end based on profit and bottom end based on profit. So we'll create a set. Top end, we'll select top end based on profits. So this is top end profits. Similarly, we'll create bottom end. We'll go to top, change it to bottom. So this is bottom end based on profits. We have created two sets now. We created two sets now. So we have created two sets on customer names, top end based on profit and bottom end based on profit. So now we'll create a combined set to show all members, top end and bottom end. We'll select these two sets and create a combined set. Here we will use it. We'll create a set called top end plus bottom end. Okay. Top end plus bottom end. So the option we have to use is all members in both the sets. Click on OK. So we'll drag the combined set into rows, profit into columns, and colors as well, color as well, and show members in set and sort it. So in this view, this way you'll get, so we'll also show parameter control. So these are the top n and top 5 and bottom 5 customers based on profits. Similarly, if you change the parameter to 10, so we'll get top 10 and bottom 10 customers based on profits in a single view. So this is also one of the important real-time scenario uh, functionality that you would be asked to know or required to know, and one of the most important interview questions as well. Okay, right. So you may be asked, how will you be able to create top n and bottom n uh, dimensions based on a measure in a single view? So the answer is using sets. And what sets? Combined sets, and are using all members in the sets. Okay, is that clear?
Yep.
Yeah. So now, so we have to note here that so combined sets will act as normal sets. So all these combined sets will act as a normal sets. So on a combined sets, again we can create another combined set. So using this set, so you can, using two combined sets, you can create one more combined set on top of it. Okay. So because it acts as normal set. Okay. So you can,
But even in that case, the dimension should be same, right? Consistent across all the combined.
exactly. So that is that condition applies for this also, because this is
Okay.
eventually a normal set. Okay. So what conditions apply for a set also applies to a combined set, right? So right, this way we can create all the sets using dimensions. So I've told you that you cannot create sets on measures. We can only create sets on dimensions. So to create sets on measures, so on the measures, it is not possible to create sets. So if you want to perform similar kind of set analysis on measures, then we need to create bins. Okay, there is a concept called bins. Okay, so sets can be created on dimensions, and the same feature can be applied using bins on measures. Bins on measures. So on measures, it is not possible to create sets. If you want to perform similar kind of analysis on measures, then we have to create bins. So what is a bin? Bin is nothing but a container which holds the required values depending on the bin size. So um, measures and dimensions behave differently, right? So dimensions have those the values, the entries within or members within dimensions are limited in number. So for example, if continent, there will be only 5 members. But for measures, if sales is there, it will have a lot of members or values in it. Okay, so at any given point of time, measures will have a lot of data when compared to dimensions. Okay, members will have always a lot of data compared to dimensions. So using bins, we can perform set kind of an analysis on measures. So using bins. So what is a bin? Bin is nothing but a container which holds the required values depending upon the bin size. So for example, sales is a measure. So we can create a bin on sales based on a defined value. Okay, so we'll see with an example so that you can understand that better. So bin fields are indicated with a histogram icon. So when you create a bin, it is indicated by a histogram icon like this. Okay, so it is indicated by a histogram icon like this. Okay, right. So we have to note here that if we create a bin, then Tableau creates that fields under dimensions. So you've just seen that uh, when you create a set, it will be created under sets tab under data window. However, if you create a bin, that bins will be created under dimensions tab. Okay, they will be created under dimensions tab. So also bins are used to identify the distribution of measure values or to perform distribution analysis. So basically, most of the cases, bins are used for distribution analysis. Okay. Okay. So we'll perform few tasks to understand the concept of binning. The concept of binning. So in this task, so we will identify sales distribution values in the range of 10,000. So we'll see the sales distribution values because bins are used for distribution. So we'll identify sales distribution values in the range of 10,000. So we'll right click on sales and select create bins. Create bins here. So this will open a window like this. So we have to enter the bin size. So we have to enter the bin size. So we have to name this as, okay, we have to name as a unique field name. And also so because we want bin size to be 10,000, so we have to enter that number here and click on OK. So this will create a bin under dimensions. This will create a bin under dimensions like this. Okay, so denoted by a histogram icon under dimensions tab. So from dimensions we have to drag this sales bin into rows and sales from measures into columns, and select percentage of table. Okay, so here we are actually binning the data like this. Okay, so we have to note here that we can create bins only on a non-aggregate measures up to Tableau 8. From Tableau 9, it is possible to create bins on both aggregate and non-aggregate measures with the help of level of detail functions. So we'll discuss about LODs in our future class. So for the time being, remember that it is possible to create bins on both aggregate and non-aggregate measures with the help of LODs from Tableau 9. Okay. So what are we doing? So we are binning the data into different groups, different bins. So uh, the bin size is 10,000. So for every 10,000, we are binning the data of total sales and showing it in a view like this. Okay, right. So this is how we can create bins and then show in the view like this. Now, so you can also create a dynamic bin similarly. So we'll perform one more task. So now we'll identify the profit distribution value based on the size dynamically. So we'll right click on profit here and create a bin. We'll enter bin name as dynamic bin. Okay, we'll enter the name as dynamic bin. In size, we'll click on create a new parameter and enter the parameter name as bin size. And allowable values as all. Click on OK. Okay, and click on OK here and display the parameter called bin size. Okay, it is already there. Fine. So we'll drag the dynamic bin from dimensions into rows. And profit into columns. Okay. So here you can define your own size of the bin. Okay, so by defining the size like this, so you will be able to get uh, the profits based on the binning that you define. For every 10,000, the data is being binned like this to show negative and positive profits like this. Okay, so you can create negative dynamic bin and also static bins, um, as per the examples shown here. So this is a static bin, constant bin, and this is a dynamic bin. Okay, so if you want to create variable size bins, then we have to use calculations also. Okay, bins can be controlled dynamically using parameters as well, like this. Okay.
So, Kranti, is this sets also can be controlled by controlled values? Because we have seen parameters.
Mm. So even you create. So what's your question? So are you
Yeah,
asking?
in the
Mm.
sets also can be controlled by calculated value, because you said bins can be controlled by parameter or
Yeah.
controlled like calculated value. So even using sets also like that.
Um, so yeah. So the same applies with the sets also.
Sets also okay.
Yeah. Right. So now, so so we have seen here that it is possible to create bins on measures only. So as we can create sets only on dimensions, we can create bins only on dimensions here. Okay. Right. So I'll give you few assignments so that you can go through those in detail. Okay. Right. So now we'll discuss few of the use cases of sets. So where do we use sets and where do you use bins? Okay, so we use sets in all the set analysis like this. Sets, this is called set analysis, and we also use sets for top end and bottom end analysis. Okay, we also use sets in top and bottom analysis like this. Top and bottom analysis using sets, and we can also use sets for reusability. So we can create a subset of a dimension and you can use that any number of times in our different views or different visualizations. So for reusability we can use sets, so that is also one of the use cases. Okay, so sets can also support calculations. So uh, as just asked in the question, so sets also support calculations. Okay, so those are the different sets and use cases for sets. And what are the different use cases for bins? So bins can be used in distribution analysis. So those can be used in distribution analysis like this. Um, and all these bins are dynamic in nature. So you can change the bins and also see the same in distribution analysis. So these are the different types use cases that you that are applicable for sets and bins. Okay, so we will take a quick break now. We are done with this concept called sets and bins now. So once we come back, we'll look into groups and hierarchies. This is our next topic. Okay, yeah, see you in 2 minutes. Bye.
Okay. Bye.
Right. So are you able to hear me?
Yeah, Kranti.
Yeah. So we'll discuss some of the interview questions on sets and bins. So you may be asked what is a set and what are the advantages of it. So you know the answer, right? So we have discussed about
Mm.
all those topics now. So you may also be asked what is a bin and what are the advantages of a bin. And you may be also asked to explain within examples. So you can you can actually create a bin and show them with an example like this. So you may be asked how to display top n and bottom n in a single worksheet. So if you are asked about that question, so you have to perform using combined sets like this. So the question would be like how to display top n and bottom n in a single worksheet. So this is the answer. Okay. So you may also be asked, is it possible to create sets on a non-aggregate measures? Okay, so the answer is yes, it is possible to create sets on non-aggregate measures using LOD functions from Tableau 9. Okay,
I think is it sets or bins, I guess.
yeah, it is bins actually.
Okay.
Yeah, sorry, bins. Okay, so um, you may be asked also how to create bins and is it possible to create calculations using sets or bins? And the answer is yes, you can create that. Okay, so you may also be asked about some of the use cases of sets and bins. So you can say that using the use case of sets are set analysis, top and bottom analysis, reusability, and calculation supportability. And for bins, distribution analysis and dynamic in nature. Okay, right?
Yeah.
These are all the different questions you may be asked. You okay? So you may also be asked about combine sets. How you can combine sets? So you know the answer, right? So you can
Yeah.
combine sets using the procedure explained now.
Kranti, here I have only one question.
Mm.
So, for all the dimensions, measures, sets, and parameters, they have their own, kind of header, and whenever you create, it will go underneath of that. So,
Mm.
is there any reason only bins, when you create, it is going into the dimensions? Is it a limitation of Tableau, or I mean to say, Tableau itself, the product they have set up like that?
Yeah. See, if you understand the nature of a bin, so it is
Mhm.
actually segregating the data. So if you see the visualization here,
Mhm.
so so what is a
It is.
dimension and what is a member of a dimension? So within each dimension or a field in the dimension, so if you look at the values within that, so
Mhm.
the data is divided into subparts, right? So in this
Mhm.
case, region is divided into central, east, international, south, and west. Similarly, what are we doing using bins? We are actually dividing the complete profit measure into different
Mhm.
subparts. So, so
Yeah.
that's why it is actually placed under dimensions. So as you can see,
Mhm.
these are the different subparts that we have divided the data into.
Mhm.
So this is also acting like a dimension, right?
Yeah.
By doing this. So the functionality is similar to a dimension. That's why it is
Dimension.
clubbed into dimensions
Dimensions.
rather
Okay.
than as a separate bin tab.
Yeah, that makes sense. Yeah. Thank you. I understood. Yeah.
Right. Okay. So we'll move on to the next topic called groups and hierarchies. Groups and hierarchies. Okay. So right. So what are groups in Tableau? So groups are used to combine the values into the higher level categories. Okay. So using groups, we can combine the values into higher level categories. Combine the values, okay, into higher level categories. Groups are also used to perform multi-value set analysis also. So groups are also used to perform multi-value set analysis. So if you want to combine the values into higher level categories, then you use groups. So we'll see what a group is using a task now. Okay. So in this task, we'll create a group on the customers with 4 values: A, B, C, others and others, where A group contains all the customers whose name is starting with A, and similarly with B and C. And other should contain all the remaining customers. Okay. So here we'll right click on customer name and click on create group. So similar to the set, we have to go to create and then click on group. You have to select all the customers whose name is starting with A. Starting with A, and click on group and enter the group name as A group. Okay. Similarly, we'll repeat for B and C. Right. To add other group, click on include other. And click on apply and OK. And yeah, you can also rename the other group as D to Z group. So this is a complete uh, customer name value subdivided into different groups. Click on apply and OK. So we'll now drag customer name group and customer name into rows. So by doing this, a group will be created like this. Now we have created groups in customer name. So a group is indicated by a clip icon like this. So we'll move these two into rows. Click on all members. Right. And profit into columns. So this is one way of doing grouping. Okay, so here all the groups in Tableau are static in nature. Okay, to create dynamic grouping, we have to use calculations. We'll see how to do that in our next example. So here, this group is static in nature. So we have to remember here that groups can be created on both dimensions and also measures. We can create groups on both dimensions and measures. So here we have created groups like this. So in group A, we have all the customers based on um, the first letter starting with A, group B, group C, and also the others group like this. So this is the manual way of manual grouping. So if you want dynamic grouping, so we can perform the same. We'll duplicate this sheet, and to create the dynamic group in on customers, we'll create a calculated field with formula. We'll create a calculated field. We'll name it as dynamic grouping. Dynamic group customers. Right. So we'll use if condition. If left off customer name comma 1 equal to A, then A group. Else if so people generally use else if and also else if. So Tableau actually recognizes both else if with a tab or with a space or without a space. If it is always advisable to use else if without space, because Tableau actually calculates else if as a separate if condition starting from here. So it is always advisable to use else if without a space. So else if left off to B, then B group. Else if left off is equal to C, then C group. Else other, or D to Z, whatever you want. End. So the calculation is valid. Click on OK. You can use uh, this grouping also into the view. This will also create the same view. So if you want to create a group then manually, you can create that, or you can use a formula or a calculated field to create a group based on the customer name like this also. Okay. So this the second option is a dynamic grouping. The first option is a static grouping. Okay. So now this is a grouping on a dimension. So now we will do grouping on measure. So we'll create a group on profit. If the value is positive, group it under profit, and if it is negative, we'll group it under loss. Okay. So we'll right click on profit and select create group. So in group window, we'll select all the negative values and click on group and enter group name as loss. Similarly, we'll click on um, include other, and we'll rename it as profit. Apply. Okay. We'll now use profit group into rows and profit into columns. Okay. So these are the profit numbers and these are the loss numbers. Okay. So using a group on a measure, we can show a visualization like this. Okay. Right. So we have to note here that Tableau creates groups only on non-aggregated measures up to Tableau 8. From Tableau 9 on both non-aggregate and non-aggregated measures, we can create groups with the help of LOD functions. Okay, so level of detail function. So using LODs, we can create group on aggregate and non-aggregate measures also from Tableau 9. So we will see when we are covering the topic of LODs, okay, about this. So with the help of groups, also we can perform similar kind of a set analysis. Okay, so similar to a set, we can perform same analysis using groups as well. So one more advantage of grouping is visual grouping. So there is also a type of a grouping called visual grouping. So we will see what a visual grouping is all about. Okay. So in Tableau, it is possible to indicate required grouping of values in one color and remaining values in another color with the help of visual grouping. Okay. So in Tableau, we can create um, one group into one color and other group into another color. So using visual grouping. So all this visual grouping has to be performed at the visualization level only. With this visualization level, this visual grouping is performed at only at visualization level. Okay, so visual grouping is based on groups. Okay, so visual grouping is based on groups which are static in nature. To perform dynamic visual grouping, you have to use sets. So visual grouping is static in nature. So to perform dynamic visual grouping, we have to use sets. So we'll perform a task to see that. Okay, so we'll display top 10 customers. So we'll display top 10 customers based on sales, based on sales. So we'll indicate first 4 in one color and next 4 in another color and remaining in another color. Okay, this is also one of the interview questions that you may be asked. Okay. So using visual grouping, you can answer this question. So basically, you'll will asked if there are top 10 customers based on sales. So how will you indicate top 4 in one color, next 4 in another color, and the remaining in another color? So this is also one of the interview questions. So we have to drag customer name into rows now and sales into columns. Sales into columns. Okay. Now we have customers based on sales. In customer name, so we'll place the customer name into filters. We'll go to top, select by field and choose top 10. And the field is sales. The aggregation is sum. We click on apply and OK. We'll sort the view in descending order. So we'll select first four customers. So four items are selected, and a tooltip appears like this. In tooltip, click on group. This is the group icon. So click on group. Okay. So automatically Tableau will indicate first four in one color and remaining in another color like this. Okay. Blue and gray. So the next step is we have to select next four customers, and the tooltip appears here, and then tooltip click on group again. Okay. So similarly for last two customers, but it is a static as we are using groups, so make it dynamic use set also. Okay. So here using this functionality like this, you can create different colors for top four and the next top four and the others with different colors like this. So within a single view, so you can perform visual analysis using grouping like this. Okay. So this is a static grouping. This is static grouping. So we can also perform dynamic grouping using a calculated field, using a set, sorry. Okay. Right. So now we'll see how you can perform a dynamic visual grouping. So first we will create two sets, top four customers based on sales and top eight customers based on sales. We'll create set using top four customers based on sales. Duplicate this and create one more set. We'll edit this set to top eight customers based on sales. Go to top and change it to 8. Click on apply and OK. So we'll create a combined set on top 4 and top 8 customers sets with the name top 5 to 8 customers. So top 4 to 8 customers. We'll choose these two, create a combined set. And we'll select here top 8 customers except shared members. So we'll name this as top 5 to 8 customers. Okay, this will have only top 5 to 8 customers. So now we'll create a calculated field with a dynamic customer group with formula. Okay, so we'll create calculated field and name it as dynamic customer group. So we'll write a formula if condition if top 4 customers on sales, then top 4, else if top 5 to 8 customers, then top 5 to 8, else others. And click on OK. So here we'll drag customer dynamic customer group into colors. So we'll remove this and we'll drag dynamic customer group into colors. So this will create a similar colors like this. So using dynamic functionality also we can create visual grouping, and also using manual way also we can create static visual grouping. Okay, these are the two ways that you can um, use. You can change the colors as well, so you can change the colors based on your requirement. So you can change the others to gray, top 5 green, and top 4 with maybe, yeah, blue, like this. So you can change as per your requirement. That's not an issue. So we have to note here that in visual grouping, Tableau is automatically creating the group and it is adding that group to color legend of the marks card. Okay. So in visual grouping, Tableau is what it is doing in the backend. It is automatically creating the group and it is adding that group to color legend of the marks card. So when you are adding a group, it is creating a group. Okay, and it is adding the group to the color legend automatically. So when we are doing the visualization, we have seen that that color legend is automatically added to the marks card here. So to ungroup the members from the group at the visualization level, select the required members in the tooltip and click on ungroup members. Okay, so you can click on the visualization and click on ungroup members. So by selecting the group, So you can click on this ungroup, and you will be able to ungroup the members from the manual group. So by selecting ungroup, you'll be able to ungroup the members like this. Okay. So basically, so multi-value set analysis is based on groups is static in nature. So to perform a dynamic multi-value set, dynamic multi-values, so you have to use set analysis using sets. Okay, right. So we can also perform multi-value set analysis using groups. Okay. So I will give you a few of the tasks to perform. So you can do that using these examples. If you have any questions, you can get back to me. Okay. So you have to note here, uh, it is not possible to create calculation fields on groups up to 9.3, Tableau 9.3. Okay. It is not possible to create calculation fields on groups up to 9.3. Okay. From earlier after the latest versions, you will be able to do that. Right. So we have one more concept called hierarchies. This is about groups, visual groups, and creating groups in Tableau. So we also have hierarchies. So we have hierarchies. So what are hierarchies? So defining one to many relationships is known as hierarchies in Tableau. So there are fields like geographic fields. So a country will have many states, and state will have many cities in it. So defining this relationship called one to many relationship is known as hierarchy in Tableau. So we can create hierarchies on geographical fields as well. So in hierarchies, we will use three types of uh, drills. So one is drill down, another one is drill up, and the third one is drilling across. So in drill down, so if we view the data from one level to the next to lowest level, it is known as a drill down. So we'll see that with an example. Right. So in geographical fields, we have one to many relationships. So if it is a country like this, country will have one to many relationship with between states. State 1, state 2, state 3, state 4, and so on. And also there will be further levels like city 1, city 2, city 3, and so on. So for each state there will be different cities. And so on. Okay. So in the option to drill down, so if you go from country to state, so that option is a drill down option. Okay, if we view the data from one level to the next lowest level, it is known as a drill down. Okay, so whereas uh, if you view the data from the lower level to the next highest level, it is known as a drill up. So even when you go from state to city also, that is a drill down. It is a drill down. So what is drill up? So from city to state, that is a drill up. From state to country, that is a drill up. Now what is drill across? So if you move from state to state or from city to city, that is drill across. Sorry, so when you go from country to city, directly from country to city, that is drill across. So if you view the data from lower level to the next highest level, it is drill up. So if you view the data from one level to the required level, it is known as a drill across. Okay. So these are the different hierarchies that we use in Tableau. So we have to note here that Tableau automatically creates hierarchy for geographic and date dimensions. So in geographic dimensions, this is one of the examples: country, state, and city. Similarly, for date dimensions, there is year, quarter, month, and day. So in Tableau, for date and geographic dimensions, hierarchies are automatically created. So we'll perform a task now and try to understand hierarchies. Okay. So in this task, we'll create a hierarchy on the geographic fields. So you have to note here that to remove any hierarchy, we have to right click on the existing hierarchy and select remove simply. Okay. So we'll create an hierarchy. So the first step is to uh, select all the required geographic fields. So what are the geographic fields here? So the geographic fields are indicated by globe. City is a geographic field, country is a geographic field, and postal code is a geographic field. state is a geographic field. So for creating a hierarchy, first we have to select the required geographical field. So we'll select state, we'll click on control and select country and city. So we've selected city, country and state, and right click on it and click on hierarchy and click on create hierarchy. Okay. So we have to note here that in hierarchy, the ordering of the fields is very important. So first the order should be very important. The order should be country. The next it should be uh, re, uh, it should be state and then the city. So we have to see the hierarchy once it is created, or else we have to recreate the hierarchy again. So the order is important here. So first it should be country. So we'll remove the hierarchy now like this and then create it again. So first we'll click on country, then state, click on state and then city. Create hierarchy. Yeah, now we'll adjust the order, because in hierarchy we have to place all the geographic fields in a order that we want the drill down and drilled up and a drill across with. So so now we have country, state and city. So we'll drag the hierarchy and then drop it into rows and perform drill down, drill up and drill across. So we have country, state and city here. So when you press on the plus and minus icons here, so you'll be able to drill down and drill up. Okay. So this is on a country level. Press on country, you will get state. Press on state, you will get city level. Okay. You can remove state if you don't want to show state like this. Okay. So we have to note here that one data field cannot exist in two different hierarchies at a time. Okay. One data field cannot exist in two different hierarchies at a single time. Okay. Also note that one hierarchy can contain different types of dimensions. Okay. So one hierarchy can contain different types of dimensions as well. So in the hierarchies, it is possible to place the lower level fields before the higher level fields. However, it is advisable to keep everything in order so that you can drill down and drill up. However, it is possible to place lower level field before the higher level field as well. Okay. Right. So this way you can create hierarchies. Also, you can create products, departments, and category and item also. So similarly, um, item is the lowest level, okay, of any product. So item, product, category, and department. So first is the department. So we'll create one more hierarchy. So we'll remove this. So we'll create one more hierarchy using department, then category, then product, or a item or item. These are the three levels. Now hierarchy is indicated by this icon, which is creating different paging. Okay, this is page folding. So, okay, this is page folding icon. You can identify a hierarchy using this icon, which is a page folding icon like this. So drag that into the field. So first sort department, category and item, and then drag that into rows. So first you have department, then you have categories, and then you have items like this. Okay, so you don't want item, so just go back with department and categories like this. So this way you can create hierarchies on dimensions. Okay, so you may also want to see different differences between sets, bins and groups. You may also want to see differences between sets, bins and groups. So now we have seen sets, bins, groups and hierarchies. Okay, so we'll now see some differences. So what does a set contain? Set contains subset of the dimensional values. Okay, sets contain subset of the dimensional values. Okay, so what about bins? Bins contain a subset of measure values. All the bins contain subset of measure values. What does a group contain? Groups, so groups are of dimensions and measure values both. So groups contain both measures and dimensions. Measures and dimensions. Groups contains both measures and dimensions. Okay, right. So what are the use cases of sets? Sets can be used in set analysis, top and bottom and analysis. So what about bins? So the use case could be to identify the distribution of measure values or distribution analysis. So what about groups? To perform multi-valued set analysis or visual analytics. To perform visual analytics or multi-valued set analysis, you can use groups. So what is the storage location of sets? Storage location is under sets tab under data window. Under data window, the storage location is under sets tab. So what about bins? Under dimensions. Bins are stored under dimensions. And what about groups? They are also stored under dimensions. Groups are also stored under dimensions. When you come to calculations, we can create calculations on sets. So we can create calculations on sets. So however, we cannot create calculations on bins. We cannot create calculations on bins. Okay, so in groups we can create calculations on groups from Tableau 10. So from Tableau 10 we can create calculations on groups as well. Okay, so what are the different icons to differentiate? So sets are indicated by a Venn diagram like this. So and bins are denoted with a histogram icon like this. And uh, groups by a clip icon or a paper folding like this. And also a hierarchy by this icon. Okay, so coming back to where we can on which dimensions or measures that we can create these three items. So we can create sets on dimensions. We can create sets on dimensions, whereas we can create bins on measures. So we can create, coming back to groups, we can create groups on dimensions as well as on measures. Okay. So when you are combining these items, so we can combine two sets into a combined set. Similarly, we can combine two bins into a combined bin as well. So also we can combine two groups into a combined group as well. Okay. So coming back to the behavior, both the sets are both static and dynamic. Okay. However, bins are only dynamic in nature and groups are static in nature. Okay. So these are the different differences between sets, bins and groups. So uh, we'll look at some of the interview questions now. So you may be asked what is a group and what are the different advantages of a group. So group is actually used to uh, give the higher level of higher level of dimension, higher level of dimension to a to a category. That means, so groups can be used to combine the values into a higher level of categories. Okay. So you can use groups in visual grouping to indicate by different colors like this. Okay, so this is one of the important interview questions. So you may be asked how to show top 4 countries in one color and next 4 in color 2 and the remaining with color 3 out of out of out of 50 countries. So that may be a question that may be asked. So you can use that using do that using visual grouping. Okay, so you may also be asked for different differences between sets, bins, and groups as well. Okay. So these are the different topics that I wanted to cover on sets, bins, groups, and hierarchies. Okay. So is that clear?
Yeah. Yeah, Grant.
Yeah. So we'll discuss different types of charts in tomorrow's class, and also some calculated fields. Okay. So we'll kickstart making different visualizations from tomorrow after we are done with calculated fields. Okay.
Okay. Yeah.
Okay. Okay. Bye bye.
Bye.